The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. Hope all are doing good, and days are just running. It's now June, July, August, now it's September. I know we are also busy with our portions, and I hope everybody are on with your syllabus and the notes that you are writing, also doing your homeworks. This is our need, so don't wait for somebody to push you. If you want something to achieve, it is you who should decide to start that. Maybe you will be having a starting trouble, but never get lazy, children. Be active. I know, though we are not coming to school, because when we come to school, we have a tendency to become active. We are always energetic. But at home, everything is taken for consideration because we have our own time. But time comes only once. Once the time is lost, you cannot get it back again. So use the time wisely. Whatever is the syllabus that is being covered, you start doing revision, because as of we are completing the portions, we are not getting time for revision for each lesson. So from your side, you take the initiative. You have the whole day with you. Put yourself a timetable, start learning the portions. Okay. So last class we were learning about Faraday's law of electrolysis, product of electrolysis. I have shown a video to you which you will get an idea of how the electrolyte plays an important role, or the nature of electrode plays an important role in designing the oxidation and reduction reactions. So today we are going to learn about batteries, fuel cells and corrosion. Batteries, it's a common term which we have been using in our daily life, because whatever that comes, we use any electronic gadgets, we use the term battery. What is a battery? Battery is a combination of cells which are connected in series. What do you mean by series? Together when it is connected. In physics you would have been learning about series and parallel connection. Series means which goes together along. Parallel means which cannot be joined, right? Parallel lines can never be joined. So cells are nothing but these are connected in series. Different cells connected in series, combination of cells connected in series will make up a battery. What is a cell actually? Why do we use a cell? What is happening in a cell? That is actually a source of electric energy. You use a torch, you use an electric bulb, you use transistors, you use clock, whatever you use it is a source of electric energy. But in few, what happens is that the chemical energy, because it has got chemicals inside it. Any cell has got some chemicals inside this. Those chemicals will undergo a chemical reaction. It is actually a redox reaction in the form of a redox reaction. What is a redox reaction? Reduction and oxidation taking place simultaneously. So the chemical energy taking place in the form of a redox reaction, which will convert into electrical energy, is a cell. So what is a cell? Cell is a source of electric energy. How that electric energy has come? It has come from the chemical energy in the form of a chemical equation which takes place as a redox reaction to produce this electrical energy. Now when I say battery, there are different types of batteries. Some of the batteries we can use only once. But some batteries we used to recharge it again and again. We used to charge it often. So those are basically of two types. We have primary battery and secondary battery. What are primary batteries? Primary batteries are those which can be used only once. You can use that battery only once and then I have to throw it. Right, you put in your clocks, you put in your transistors, you put in watches, right, all those are cells or batteries which can be used only once, means they cannot be chargeable, non-rechargeable, you cannot recharge it again. The reaction takes place only once, it does not take place in the reverse direction. In primary battery, the reaction takes place only in one direction, it cannot take place in the reverse direction. Those are called as primary battery. Example, you have dry cell, you have mercury cell. Dry cell often can be used in transistors and clocks. Mercury cell you can see used in watches, that is a watch that we use, right. So, this is a primary battery. Now, what are secondary batteries? Secondary batteries can be used again and again. Now, the efficiency of secondary battery is such that how many cycles of charging and discharging it can do. What is discharging? When I use a battery, it gives its energy to the device, that is discharging. What is charging? When I put it for charge, again the battery gets recharged again. So, how many cycles of charging and discharging it can undergo, that shows the efficiency of a secondary battery. So, these are rechargeable, which means when the current is sent in the opposite direction, the reaction takes place in the reverse direction. I told in primary battery the reaction takes place only in one direction, but here the reaction can take place in the reverse direction as well. Example, you have lead storage battery, or you can say nickel cadmium storage battery. Now, these are most probably used in automobiles, inverters, right, and you can also see these laptops can be recharged, or mobiles. So, those are nothing but secondary batteries which can be recharged. Now, in detail we will be learning about dry cell. Of course, mercury cell is also there, but the most important is dry cell, which we also called as Leclanche cell. So, these are actually the galvanic cells which are used in the place of batteries. So, we have already learnt about galvanic cell, what is happening. This is a Daniell cell, that is oxidation reduction happening. The same concept we will learn in detail about dry cell, mercury cell, also about the secondary battery. Once I explain this dry cell and mercury cell, you will see a video about the dry cell and mercury cell. Those reactions are very important, children. It may not come as a whole, but they may ask in 2 marks or 3 marks. Explain dry cell with the reactions, or what are mercury cell. Write the oxidation and reduction reaction at anode and cathode. Similarly, write a short note about lead storage battery. So, these are often asked questions to us, or they may ask in 1 mark also, which is a primary battery. Give an example of a secondary battery. So, these are very important. So, now we will learn about primary batteries, that is dry cell and mercury cell now. Yes, children. Now, we will learn about primary battery, that is dry cell. You can see a picture of a dry cell which has got different parts, that is a zinc case and also carbon rod, a porous rod in the center surrounded by an electrolyte. Now, any cell will have 2 important electrodes, that is anode, cathode. Now, in this dry cell, anode is made up of a zinc case and cathode is nothing but our carbon rod, which is surrounded by a mixture of manganese dioxide and powdered carbon. So, manganese dioxide and powdered carbon will be mixed, which will make up a carbon rod to form the cathode. Now, apart from these 2 electrodes, there is an electrolyte. What is an electrolyte? Electrode can be any paste. So, this moist paste of ammonium chloride and zinc chloride will be acting as an electrolyte to fill the space between the electrodes. So, there are 2 electrodes. Now, the space between those 2 electrodes will be filled up by moist ammonium chloride and zinc chloride. So, those will act as a combination. That combination will act as an electrolyte. Now, what is the use of electrolyte? Now, let us see. Now, once the reaction starts, how the reaction is going to happen? At anode first, zinc will start losing electrons. So, here you can see zinc losing electrons to form Zn2 plus and 2 electrons. So, we know any metal will lose electrons to become a cation. So, zinc loses 2 electrons to become Zn2 plus. Now, that Zn2 plus will get into my electrolyte, which is a combination of ammonium chloride and zinc chloride. So, when Zn2 plus get into my ammonium chloride, electrons also move through that. Now, what happens is that in ammonium chloride, ammonium ion, that is NH4Cl will give NH4 plus Cl minus. So, that ammonium ion will take up the electron in the presence of manganese dioxide to form manganese oxohydroxide. What does it form? Manganese dioxide combined with ammonium in presence of an electron, that is, it accepts an electron and form manganese oxohydroxide and releases ammonia. Now, here if you want to balance this, you can put here 2, 2, 2, no issues children. Okay, there is no issue to balance it, but in your textbook it is not given. But what we have learnt in the previous classes, the number of electrons in the oxidation and reduction should be balanced. So, you can multiply this with 2, that does not matter a lot. Okay. So, what is happening at cathode? Ammonium ion from ammonium chloride will take up the electrons in presence of manganese dioxide to form manganese oxohydroxide and releases ammonia. Now, what is happening now? This ammonia which is released at cathode will combine with Zn2 plus in the electrolyte to form a complex. So, Zn2 plus will combine with ammonia to form ZnNH3,4 with the square brackets you put 2 plus. This is a whole complex that will be produced in the reaction. What is the overall reaction? You know what is overall reaction? The electrons get cancelled. So, Zn plus this ammonia also is there, this ammonia, 2 ammonia is there, so 1 ammonia can get cancelled. But here what happens? When you cancel, when you take these two reaction, anode and cathode, Zn is here, 2NH4 plus 2MnO2 gives Zn2 plus 2MnOH plus 2 ammonia. The electrons and electrons get cancelled. Why do we write the overall reaction? Because overall reaction only maintains the electrical neutrality. A combination of oxidation and reduction reaction happens together simultaneously to maintain the electrical neutrality. So, this is called as a dry cell. I will repeat once again. In dry cell, anode is a zinc case, cathode is carbon which is surrounded by manganese dioxide and powdered carbon, and we have electrolyte which is moist ammonium chloride and zinc chloride. Now, in the electrolyte, ammonium chloride will dissociate, will be present as NH4 plus and Cl minus. At anode, zinc undergoes oxidation. Zinc loses 2 electrons to become Zn2 plus. So, Zn2 plus will start getting into my electrolyte and electrons also start moving along the same direction. That electron will be taken up by the ammonium ion in the presence of manganese dioxide to form manganese oxohydroxide with the release of ammonia. So, that ammonia which is released will combine with Zn2 plus to form a complex, and we have written the overall reaction which maintains the electrical neutrality. Now, what is the cell potential? Cell potential means the voltage of this dry cell. It is around 1.5 volt. This can come in 1 mark question. The cell potential for dry cell is around 1.5 volts. So, you can use it only for a small purpose, not for a big industrial purposes. So, with this our dry cell is over. Now, we will learn about mercury cell. I hope children you are able to understand this. Now, we will learn about mercury cell. I told mercury cell can be used in hearing aids and watches, right. Similarly, just similar to dry cell, mercury cell also has an anode, cathode and electrolyte. Now, here there will be an inner steel case which will be surrounded by the outer steel case. You can see the picture. Now, here anode will be a combination of zinc mercury amalgam. You call zinc mercury as amalgam. So, that will be anode. And cathode is paste of mercury oxide and carbon. Remember, anode is zinc mercury amalgam and cathode is paste of mercury oxide HgO and carbon. And what is an electrolyte here? It is a paste of potassium hydroxide and zinc oxide. A paste of potassium hydroxide and zinc oxide will be acting as an electrolyte. Now what is happening here? Similarly, in potassium hydroxide, what happens? Hydroxide ions will be present. How the reaction happens? The main reaction is the reaction between mercury oxide and zinc. The reaction between zinc and mercury oxide will be causing the entire redox reaction to happen. At anode, what is present? I told you, zinc mercury amalgam. So this zinc mercury amalgam will take up the hydroxide ion from the electrolyte. Electrolyte is KOH. So from KOH, zinc mercury amalgam will be taking up my hydroxide ion to form zinc oxide and water with a release of 2 electrons. I repeat again, zinc mercury amalgam will take up the hydroxide ion from the electrolyte to form zinc oxide, water and with a release of 2 electrons. Now what is happening in cathode? There are electrons which are coming into the cathode part. Those electrons will be taken up by the mercury oxide. I told you HgO and carbon paste is present in cathode. So this mercury oxide will take up the 2 electrons and get reduced to mercury 1. HgO will get reduced to Hg and release hydroxide ions. That is happening at cathode. Now what will be the overall reaction? I told you we need to write the overall reaction to maintain electrical neutrality. So water get cancelled, electrons get cancelled, hydroxide ion get cancelled. So what is remaining now? Mercury amalgam plus HgO will give zinc oxide plus mercury 1. So this will be my overall reaction. And what is the cell potential? It is around 1.35 volt, which is always constant, does not change. 1.35 voltage. So I'll just repeat mercury cell again. Mercury cell is a primary cell or primary battery which can be used in hearing aids and watches. It has anode and cathode. Anode electrode is made up of zinc mercury amalgam. Cathode electrode is made up of paste of mercury oxide and carbon, and electrolyte is a combination of potassium hydroxide and zinc oxide. And what is the reaction happening at anode? At anode, zinc mercury amalgam will take up the hydroxide ion from the electrolyte to form zinc oxide with the release of 2 electrons. Those 2 electrons will be taken up by mercury oxide to get reduced to mercury 1. And we have the overall reaction and also the cell potential as 1.35 volt. So children, I think you understood mercury cell clearly. Now with this, our primary battery gets over. Now we will be learning about our secondary battery.
Batteries and fuel cells. A battery is an arrangement of 2 or more galvanic cells connected in series. It is a portable electrical energy source. Commercial batteries are of mainly 2 types: primary batteries and secondary batteries. Primary batteries are not rechargeable. The electrode reactions cannot be reversed by an external electric energy source, and the reactions in the cells occur only once. After use, they become dead. Dry cells and mercury cells are 2 common examples of primary batteries. In secondary batteries or cells, the reactions can be reversed by an external electrical energy source. Therefore, these cells can be recharged by passing electric current and be repeatedly used. Such cells are called storage cells. Examples of secondary cells are lead storage cells and nickel-cadmium storage cells. Let's learn about the different types of commercial batteries. Click a tab to learn more. Dry cells are used in torches, tape recorders, and calculators. A dry cell consists of a zinc anode made up of a zinc cylinder filled with a moist paste of ammonium chloride and a small amount of zinc chloride. The graphite rod is the cathode which is surrounded by a black paste of manganese dioxide and carbon powder. The zinc case has an outer cardboard insulation. Zinc is ionized and dissolves in the electrolyte. The electrons travel through the external circuit and are taken up at the cathode, resulting in the discharge of ammonium ions from the electrolyte. At the anode, zinc ionizes. It loses electrons and forms zinc ions. At the cathode, ammonium ions from the electrolyte accept the electrons in presence of manganese dioxide to give manganese oxohydroxide and ammonia. The overall reaction that maintains the flow of electrons in the cell is the reaction between zinc, ammonium ions, and solid manganese dioxide. Mercury cells are used in small electrical circuits like those in hearing aids, watches, and cameras. The electrodes consist of zinc as the anode and mercuric oxide as the cathode. The anode and the cathode are separated from each other by a porous material soaked in a paste of potassium hydroxide and zinc oxide, which acts as the electrolyte. The entire setup is enclosed within an inner steel case covered by an outer steel case. Electrons are produced due to the chemical reaction between mercuric oxide and zinc, and the resulting flow of electrons causes electricity to be generated. The following reactions take place. At the anode, zinc-mercury amalgam reacts with hydroxide ions from the electrolytic solution to give zinc oxide by loss of electrons. At the cathode, mercuric oxide accepts the electrons to give mercury and releases hydroxides in the solution. The overall reaction that maintains the flow of electrons in the cell is the reaction between zinc-mercury amalgam and mercuric oxide. The biggest advantage of the mercury cell is that its potential remains almost constant throughout its life. The voltage produced by these cells is approximately 1.35 volts.
We are going to learn about secondary batteries. Secondary batteries, I told you, they can be recharged again and again, and it is not use and throw. And these can be seen in automobiles, inverters, laptops and mobiles. The first example which we are going to see in secondary battery is lead storage battery. Now lead storage battery you can often see used in automobiles. Just similar to our primary battery, it has again two electrodes, anode and cathode. So anode is nothing but our grid of lead with spongy lead. It is actually made up of spongy lead, and cathode is grid of lead which is packed with lead dioxide. So here it is spongy lead of anode, and here grid of lead which is packed with lead dioxide. Now again you need an electrolyte which is actually aqueous sulfuric acid, which is 38%. That is 38% of aqueous sulfuric acid is used as a electrolyte. Now what is happening again? Now the reaction between the lead and the lead dioxide, lead at anode and lead dioxide at cathode, the reaction between those two is the main cause for this battery to work. What is happening at anode? At anode actually lead becomes lead 2 plus with the loss of 2 electrons. But instead of writing this, how do we write it? We write as lead solid will combine with the sulfate ions that are present in my electrolyte to become lead sulfate and release 2 electrons. When I say lead sulfate is nothing but lead 2 plus. So here lead solid will combine with the sulfate ions of sulfuric acid to form lead sulfate with the release of 2 electrons. Those 2 electrons, when it travel along the electrolyte, will be taken up by lead dioxide. So lead dioxide takes up sulfate ions and H plus ion, accepts the 2 electrons to become again lead sulfate and water. So you understood this, right? Now what will be the overall reaction? Lead solid plus lead dioxide. Why 2H2SO4? I have 2 sulfate ions and I have 4H plus, which will make 2 sulfuric acid. So I got 2 sulfuric acid, which is giving me 2 lead sulfate, right? 2 lead sulfate plus 2 water molecules. The 2 electrons get cancelled here. So this is the overall reaction. And what happens, I told you this is a secondary battery. The voltage of the secondary battery is actually 6 to 12 volts. That is 6 to 12 volts. That's why we use it for a bigger purpose as compared to that of a primary battery. But I told you secondary batteries are rechargeable. Since they are rechargeable, the current is sent in the opposite direction. So what happens exactly? The reaction gets reversed. So on charging, when the reaction gets reversed, what is happening at anode? Lead sulfate will get converted to my lead, and at cathode lead sulfate will change into lead dioxide. So this is a normal reaction. On charging, there is a reverse in the reaction where lead sulfate at cathode and anode will get converted into lead and lead dioxide. So this is lead storage battery. I repeat again, at anode we have spongy ion, at cathode we have lead which is packed with lead dioxide. 38% of aqueous sulfuric acid acts as an electrolyte. At anode, lead takes up the sulfate ions from the sulfuric acid, becomes lead sulfate with a loss of 2 electrons. At cathode, lead dioxide takes up H plus and sulfate ions, also take the 2 electrons from the anode and becomes lead sulfate. So overall reaction is the formation of lead sulfate at anode and cathode. When the reaction gets reversed, each lead sulfate will get converted into lead and lead dioxide, and the overall voltage is 6 volt to 12 volt. With this, our lead storage battery gets over. Now we will learn a little things about nickel cadmium battery. The secondary battery which we are going to learn, the next one is nickel cadmium battery. The reactions are not given in your textbook, but I have just written, children, just for your extra knowledge of nickel cadmium battery. So nickel cadmium battery, you have anode with cadmium and cathode with nickel oxide, grid of nickel oxide, and electrolyte will be a paste or moist of potassium hydroxide. What happens here is, at anode, this cadmium take up the hydroxide ion from the potassium hydroxide and forms cadmium oxide with the release of 2 electrons. So cadmium solid will become cadmium oxide with the release of 2 electrons, that is an oxidation reaction. At cathode, this nickel hydroxide takes up the 2 electrons and get reduced to nickel with +2 oxidation state. So there is a reduction here with the release of 2 hydroxide ions. So overall reaction will be cadmium plus nickel hydroxide giving cadmium oxide and nickel hydroxide with an oxidation state of +2 and with the release of water. And the overall cell potential is around 1.4 voltage. So this is what we have learned about secondary battery. So the reactions are not given, but you just learn it because in exam they may give you the reaction or just give you the cell and ask you to write out the anode and cathode reaction. So overall we have learnt about primary and secondary batteries. In that we have learnt about dry cell, mercury cell, and also we have learnt about nickel cadmium and lead storage. Now you will watch a video with nickel cadmium and lead storage, and then we will get back into fuel cells.
Lead storage cells are used in automobiles like cars, buses and trucks. The anode is a grid of lead packed with finely divided spongy lead, and the cathode is a grid of lead packed with lead oxide. The electrolyte is an aqueous solution of sulfuric acid 38% by mass, having a density of 1.30 gram per milliliter. This entire setup is enclosed within a storage compartment. Electrons are produced due to a chemical reaction between lead and lead dioxide, and the resulting flow of electrons produces electricity. The following reactions take place. At the anode, lead ionizes to lead ions by loss of electrons. The lead ions move into the solution and reacts with sulfate ions to give lead sulfate. At the cathode, lead oxide accepts the electrons in presence of hydrogen ions from the electrolytic solution to give lead ions. The lead ions moves into the solution and reacts with sulfate ions to give lead sulfate. So, the overall reaction that maintains the flow of electrons in the cell is the reaction between lead, lead oxide, and sulfuric acid.
The reaction gets reversed on charging the battery. The lead sulfate on anode is converted to lead. The lead sulfate on cathode is converted to lead dioxide. The overall reaction during charging is as shown.
The voltage provided by these cells is between 6 to 12 volts. Smaller and lighter nickel-cadmium storage cells are used in portable and cordless appliances. The cell consists of a cadmium anode and a metal grid containing nickel oxide as cathode. The electrolyte is potassium hydroxide. Reactions at the anode. Cadmium oxidizes in presence of hydroxide ions from the solution to give cadmium oxide and hydrogen. Reaction at the cathode. Nickel hydroxide accepts the electrons and reduces to nickel having oxidation state 2 and hydroxide ions. The overall reaction that maintains the flow of electrons in the cell is the reaction between solid cadmium and solid nickel hydroxide.
We are getting into the last part, that is the fuel cells. So when I say fuel cells, before getting into what are fuel cells, we will learn how we were producing electricity using thermal plants. There were thermal plants which were converting the chemical energy into electricity. Chemical energy from where? That is from the fossil fuels, which are the remains after years and years before. So those chemical energy were used to produce the water. That water will be converted into steam. That steam will run the turbines, and turbines will produce the electricity. So that's how the electricity were produced using our thermal power plants. But this was not an effective method. I mean, not that efficient method, because this caused a lot of pollution. So much pollution was caused by this way of producing the electricity. So that's why another method came, which was called as a fuel cell method. In that, fuel cells are nothing but a galvanic cells. What is happening exactly in galvanic cell, children? There are chemical reactions which are happening inside. Those chemical reactions will cause the chemical energy to get converted into electrical energy. That is what we have learnt about electrolytic cells or galvanic cell. Electrolytic cell was using electricity to produce chemical reaction, but in galvanic cell we know the chemical energy get directly converted into electrical energy. In fuel cells, what is the main advantage is that the reactants are fed continuously into the electrodes, and you can remove the products from the electrolyte compartments. There are electrodes which are present just like any other cell, in which the reactants will be fed continuously. Now what are those reactants can be? It can be hydrogen, it can be carbon monoxide, it can be methane. So these are some of the reactants which can be used. So what is a proper definition for a fuel cell is a galvanic cell that converts combustion of fuels. Combustion is nothing but burning, not only burning, any reaction that is happening with the fuels into electrical energy. So those fuels can be my hydrogen, it can be methane, it can be methanol. So those are used to produce the electrical energy directly. Such a cell we call it as a fuel cell. In this lesson, for this year, we have got a combination of hydrogen and oxygen fuel cell, which is most probably used in Apollo space stations, and also to give water, or that is to pass water for the astronauts, right? So in space stations. So that is the most effective method of producing the electricity, thereby has got a lot of scientific applications also. So now we will learn about H2O2, that is hydrogen oxygen fuel cell. We will be learning about hydrogen oxygen fuel cell. In hydrogen oxygen fuel cell, unlike other fuel cells, you do not have different anode and cathode. Both the anode and cathode are made up of porous carbon electrodes, that is graphite or carbon. Graphite is nothing but carbon only. So both the anode and cathode will be made up of porous carbon electrodes, but which will be finely coated with a platinum, that is finely divided platinum. Why do we use platinum? Platinum is actually an inert metal. So that inert metal will be used, which is a catalyst. We know catalysts are used to alter the reaction. So here, to increase the rate of reaction, to speed up the reaction, we coat the porous carbon electrodes with finely divided platinum. And what is an electrolyte used here? We have concentrated sodium hydroxide. What is exactly happening? You will see in the video, children, there is a setup with hydrogen and oxygen inlet, where hydrogen will be bubbled through this anode and oxygen will be bubbled from the cathode side. So both anode and cathode will be present like this. So one side we will be bubbling hydrogen, the other side we will be bubbling the oxygen. So at anode, hydrogen is getting oxidized. Hydrogen gets oxidized. So what has to happen? Hydrogen has to lose electron. So hydrogen will combine with the hydroxide, that is from my alkali, that is the electrolyte, to form water and releases 2 electrons. At cathode, oxygen gets reduced, because cathode we know reduction take place. So this oxygen will take up the electron to form hydroxide ion. So what will be the overall reaction is the same as the formation of water. Hydrogen with oxygen gives water molecule. So this is the overall reaction. See, this fuel cell has got more than 70% efficiency when compared to that of our thermal plants in producing the electricity. And to increase the efficiency, we can also use better electrodes, and also you can use a different electrolytes just to make up, or you can use any other catalyst to make the reaction much more efficient. So this is a hydrogen oxygen fuel cell, very simple, and it's a definite question for your board. I hope you are able to follow, children. Hydrogen and oxygen fuel. With this, our batteries and fuels are getting over. You will see a video of hydrogen and oxygen fuel now, and last part we will just see what is corrosion, which we have been learning from our lower classes, rusting and corrosion. We will just see what it is, how to prevent corrosion. With that, our chapter gets over.
Fuel cells are voltaic cells in which the reactants are fed continuously to the electrodes. The reactants are fuels such as hydrogen, carbon monoxide, methane, etc. The electrodes are designed to convert the energy from the fuels to electrical energy directly. The hydrogen-oxygen fuel cell is the most commonly used fuel cell. Porous carbon electrodes are used as both anode and cathode. Both the electrodes contain a small amount of finely divided platinum, which acts as a catalyst to speed up the reaction. The electrolyte used in the fuel cell is concentrated aqueous sodium hydroxide. Hydrogen is bubbled into the anode compartment, while oxygen is fed into the cathode compartment. Hydrogen is oxidized at the anode, while oxygen is reduced at the cathode. The overall reaction is the same as burning hydrogen and oxygen to form water. In this kind of fuel cell, the production of electricity continues as long as hydrogen and oxygen are supplied. Hydrogen-oxygen fuel cells are used to produce electric power in spacecraft, especially in the Apollo space program.
We have come to the last part of this chapter, corrosion. Corrosion is an electrochemical reaction, because when we say electrochemical reaction, because actually chemical reactions are happening inside due to the exposure to the atmospheric oxygen or moisture, that is water molecules. So it is an irreversible deterioration of materials. Materials, it can be any metal, most probably metals only undergo this electrochemical reaction, which is called as corrosion. So it is an irreversible deterioration of materials. What is deterioration? Getting lost due to the chemical reaction with the environment, or we say atmosphere or water. So metals get coated with a layer of oxygen and water. That process we call it as rust. In the rusting, you can see brown powder that is formed because of the oxide that is formed on the layer of the metal. What is rusting actually? In the corrosion of iron and steel commonly is called as rusting. If you see the reactivity series we have studied in 10th standard in the 3rd chapter, there is an electrochemical series present, right? So that electrochemical series shows us that there are more active metals and there are some inactive metals. So these active metals, they get more reacted to the oxygen and water in the atmosphere, and they undergo corrosion very easily when compared to the other metals in the series. So at anode, this iron, or you consider any metal, it loses electrons to become a cation. So iron becomes iron 2 plus with the loss of 2 electrons. At cathode, what happens? The oxygen in the atmosphere, that is, you have compartment layer of any metal, that oxygen will take up those electrons and forms a water. So overall reaction, if you see, iron takes up the oxygen, also combines with the H plus to form Fe2 plus and water. So this, when it getting exposed to the atmosphere, get converted into iron oxide, and that oxide, or you can say ferric oxide, gets converted again in the form of a rust. So that is how the metal gets rusted. Now active metals get rusted very fast when compared to the inactive metals. Now how can we prevent this corrosion? You know, by galvanization or applying paint or by grease. Galvanization is a process of applying an active metal over this metal, that is, you can apply zinc over iron so that you can prevent this corrosion or rusting. So with this, I think children, you are able to understand corrosion. So today we have learnt about batteries, primary, secondary, and also we have learnt about fuel cells, and the last one is corrosion. You will see a small video about corrosion and how to prevent corrosion, that is using that is how to prevent rusting, and then with that we will be winding out the 3rd chapter, electrochemistry. The next class I will be seeing you with the 4th chapter, chemical kinetics. And if you have any doubt with anything, please don't hesitate to call me or send me a voice message. Okay, so stay home, stay safe. Until then, see you in the next class. Take care. Bye.
Corrosion. Corrosion is the slow conversion of a metal into undesirable compounds after reacting with moisture and other gases that are present in the surrounding atmosphere. The rusting of ordinary iron is the most common form of corrosion. In moist air, iron will combine with oxygen and water to form hydrated iron oxide, a brownish-orange deposit of rust. Let's look at the conditions under which corrosion can occur. For this, you will need 3 clear iron nails, 3 test tubes, 3 rubber stoppers, cooking oil, calcium chloride, and distilled water. Begin by placing the 3 iron nails into the test tubes, which should be labelled A, B, and C. In test tube A, add distilled water such that only half of the nail is immersed. In test tube B, fill it with distilled water, completely immersing the nail. Add a few drops of oil so that a layer is formed on the surface of the water. This arrangement will prevent air from mixing with the water. In test tube C, add only calcium chloride, which will absorb moisture. Seal each of the test tubes with rubber stoppers. After 2 days, observe the nails. The nail in test tube A will show evidence of corrosion and be covered in brownish-red rust. In test tubes B and C, the nails will not show any corrosion. For the corrosion of iron to take place, both moisture and air are necessary. In test tube A, both are present, which leads to the rusting of the nail. In test tube B, moisture is present, but the layer of oil acted as a barrier preventing the oxygen from mixing with the water. Therefore, the nail did not rust. In the third test tube, the air was dry because calcium chloride absorbed moisture, so the nail did not corrode. With this experiment, we can infer that air and moisture together will corrode metals. To prevent corrosion, metal surfaces will often be coated with paints or electroplated with non-corrosive metals such as nickel. Summary: the corrosion of iron will occur in the presence of water and oxygen. Corrosion can be prevented by electroplating or painting the surface of the metal.
Mechanism of corrosion. Corrosion is defined as the gradual and irreversible deterioration of materials owing to chemical interactions with the environment. Generally, the term corrosion applies to metals. You must have seen tarnished silver or a green coating on copper and bronze. These are examples of corrosion of metals. Corrosion is the oxidative deterioration of metals, that is, metals are coated with their oxides and other salts. When iron is exposed to air and moisture, its surface gradually corrodes and gets oxidized to hydrated iron 3 oxide, which appears as a brown mass called rust. This phenomenon is known as rusting. The term rusting is specifically used to describe the corrosion of iron and steel. How does corrosion occur? Well, corrosion is an electrochemical phenomenon. Different metals corrode or get oxidized at different rates, depending on their reactivity. Active metals are more susceptible to oxidation than less active metals. Rusting leads to annual losses worth crores of rupees and has extremely serious economic implications. Let us understand the mechanism of rusting. Iron has a very strong tendency to react with oxygen, water, and other substances in an aqueous environment. This reaction leads to rusting, an electrochemical process which involves the transfer of electrons between an iron surface and an aqueous electrolyte solution. The electrolyte solution is formed when atmospheric gases such as carbon dioxide dissolve in water. Droplets of water and the iron surface form a tiny galvanic cell. Iron is oxidized at a particular spot, which acts as the anode. The electrons released at the anode migrate through the metal to another spot. Here, the electrons reduce oxygen to water in the presence of hydrogen ions. This region acts as the cathode. The electrochemical circuit gets completed and the overall reaction leads to the formation of water molecules and iron 2+ ions. These iron cations also react with the dissolved oxygen or oxygen in the air to form Fe2O3 or iron 2 oxide. Fe2O3 now gets hydrated to form iron 3 oxide, which is commonly called rust. Let us summarize the mechanism of rusting.
Electroplating. When handling chemical substances, you should always be extremely careful, including wearing protection for your eyes and appropriate clothing that protects your skin. Electroplating is a process that involves the use of electricity to coat one metal with another. Let's see how electroplating works by setting up a simple experiment and coating an iron key with copper. For our experiment, we'll need a small iron key, a small copper plate with a hole punched, copper sulfate crystals, distilled water, a glass beaker, a battery, and 3 copper wires with exposed ends. We'll begin by filling the beaker with distilled water. Into that, we'll dissolve some copper sulfate crystals. Copper sulfate solution acts as an electrolyte that conducts electricity. We'll hook one of the exposed ends of the copper wire through the key and then connect the wire's another end to the negative terminal on the battery. Using our second wire, we'll hook one end through the hole in our copper plate and the opposite end to a switch. We'll connect the switch to the positive end of the battery by the third wire. Now we'll lower the key and the copper plate into the copper sulfate solution. When we put on the switch and let electricity flow through the solution, electric current will flow through the circuit. After about 10 minutes, put off the switch and pull the key out of the solution. You will see that the key is now coated with the shiny brown color of copper. You have just electroplated iron with copper. Let's see what's actually going on inside the solution when an electric current was passed through it. The electrical current causes the copper plate to release positive copper ions into the copper sulfate solution. The positive copper ions will move towards the key, which is connected to the negative terminal of the battery, and stick to the key. Electroplating is widely used for coating metals which can easily corrode. Iron, such as our key was made of, will rust easily and is often coated with nickel or chromium. Copper ornaments are sometimes coated with gold. Summary. Electroplating is a process that involves the use of electricity to coat one metal with another. When electricity is passed through the electroplating solution, positive ions will move towards the negative terminal. Electroplating is used to coat corrosive metals for protection.